Hello everyone, this is Physics 103. This is on nuclear physics and now we are going to learn about half-life. So previously we have talked about radioactive decay, wherein an unstable nucleus will emit nuclear radiation in the form of alpha particles, beta particles, or gamma particles, gamma radiation, so that it will transition into a more stable nucleus. So as a model for nuclear decay, we assign n of t to be the number of nuclei at a specific time. So we know that as n of t, or the number of nuclei, decreases, the nucleus becomes more stable, as shown from Segre chart. So we take the time derivative of n of t to represent the decay rate, and to represent a exponential decay, we set the slope to be proportional to the amount of nuclei at any time. So the slope changes. The slope is proportional to the amount. So at any specific the amount at any specific time. So what it looks like is, so for example, here you have the amount as a function of time, and the x-axis you have time. So say at time equals 1 or 1 year, we have a very large amount of nuclei in the atom. So, and we want the slope to be negative here. So this is a very negative slope, and as we progress through time, so for example 2 years, the amount at that time after 2 years, we want the slope to be approaching 0. So maybe here you have this value of slope, and so on, 3 years, like that. So this kind of graph is an exponential decay. So that's why we need a negative sign here to represent the exponential decay. If this is positive, it will represent an exponential growth. So let's find the function n of t from this relationship. So we have the derivative of n of t equals, earlier we have said that it is proportional to the amount at any time. So we assign a proportionality constant, lambda, times the amount n of t. So we are going to solve this equation in terms of n of t. Dividing by n of t, and here we have lambda dt, and then we integrate. So dn of t over n of t from n naught to n, this will evaluate to a natural logarithm. So ln of n of t from n naught to n, and on the other side we have minus lambda times t. So let's evaluate this integral. We have ln of let's call this also n of t. So ln of n of t minus ln of n naught. Equals minus lambda of t. So we can simplify this expression further. Ln of n of t over n naught equals minus lambda t. And then we exponentiate both sides. e to the minus lambda t. And then we know from rules of exponentiation, we have n of t e to the minus lambda t. And then now we have our expression for the amount of nuclei as a function of time. And not e to the minus lambda t.